Lesson 4.9, Compositions involving inverse trigonometric functions. Alright, if x is between -1 and 1, so that's our domain, and our y is between -pi/2 and pi/2, this is our range, then sine of arcsine of x equals x. Why? Because these are inverses, and inverses cancel each other out. The same here. These are inverses, and inverses undo each other. It's like they cancel each other out. Alright, so the same idea. If this is in the domain, and it's also in the range, then it'll work out. So, is that in the domain? I don't know. The domain of arctangent is -infinity to infinity. Therefore, that is in the domain. Then we'll check the range of the outer. The range of the outer is -infinity to infinity. That's the tangent. So is the -14 in both? Yes. Therefore, just cancels out. You get -14. How about sine of arcsine of pi? Well, let's check the domain of arcsine. The domain of arcsine is -1 to 1. Is pi in there? No, pi is not in there. So it is not in our domain. So it is not possible. It is a domain error. How about arcsine of sine of 5π/3? Well, we need to check the domain. The domain of sine is -infinity to infinity. You can plug any number into sine. Let's check the domain, or the range, sorry, of arcsine. The range of arcsine is -π/2 to pi/2 from the previous lessons. Is 5π/3 in that? No. So we will use a coterminal angle. So 5π/3, let's subtract 2 pi. Get a common denominator, so it'll be 5 minus 6, it'll be -π/3. Is that between -π/2 and +π/2? Yes. So you may have to find a coterminal angle. Let's try another. Arc cosine of cosine is 7π/6. Alright, let's check the domain of cosine, which is -infinity to infinity. So 7π/6 is in the domain. And let's check the range of arc cosine, which is 0 to pi. Is 7π/6 in there? No. If I found a coterminal angle, it wouldn't be in there also. So let's look at unit circle idea. 7π/6 is here. Alright. So we're going to use a reference angle with the same sign. So remember, it's all students take classes. So cosine's negative here, so the other place where cosine is negative is there. So we'll be in that quadrant, quadrant 2. if this is 7 pi over 6, what's that angle? Well, this reference angle is pi over 6, so that reference angle is also pi over 6, and this would be 5 pi over 6. So they're both negative, have the same reference angle, therefore that is our answer since it is in the range. So you may have to use your unit circle and either find a coterminal angle that will land you in the range quadrants of the inverse sine or inverse cosine, or you may have to use a reference angle to get the result. Let's try a couple more. Oh, these are more interesting because they're not the same function. So we need to check our domain. Does this work? The domain of cosine is negative infinity to infinity, so it works. All right, so what we're going to do is we're going to evaluate this. Pi is here, so what is cosine of pi? Cosine is the x, so what is -1? So this is the same as saying inverse tangent of -1. All right, now, where does tangent equal -1? Remember, tangent is y over x, so I need the x and the y to be the same value, but one's positive and one's negative. So it would be here at 7 pi over 4, where the coordinate is square root of 2 over 2, negative square root of 2 over 2. Or up here at 3 pi over 4, where the coordinate is negative square root of 2 over 2, square root of 2 over 2. Remember, though, inverse tangent is in quadrant 1 or 4, therefore the answer must be 7 pi over 4. Wait, that is not in the range. The range goes from negative pi over 2 to positive pi over 2. So we need our coterminal angle. Subtract 2 pi, get a common denominator, so it'll become negative pi over 4. So remember, it's negative pi over 2 to positive pi over 2. So we need the negatives down there in quadrant 4. Let's try the next one. Is pi over 6 in the domain of sine? Yep. All right, let's evaluate it. So sine of pi over 6 is, well, that's there. Sine is the y. That coordinate is square root of 3 over 2, comma, a half. So the y value is a half. So now we have inverse cosine of a half. And so inverse cosine of a half, that's the x. Where's the x equal a half? That would be here. At this one, where it's a half, square root of 3 over 2. And that angle is pi over 3, which is in the range between 0 and pi. Let's try another. All right, first of all, we need to check our domain. Our domain for inverse tangent was negative infinity to infinity, so that works. And inverse tangent is y, or tangent is y over x. These are not on the unit circle, so maybe we'll have to use a right triangle. So the y is 3, the x is 4. Now one of these are going to be negative, since it is negative square root of 3 over 4. Remember, inverse tangent is only in quadrants 1 and 4. X is positive in both those cases, therefore the y must be negative. So if you'd like, the triangle's really going that way. Use the Pythagorean theorem to find the other side. And now, what is cosine of this angle? Well, cosine is the adjacent over the hypotenuse, so that appears to be 4 over 5. Let's try another. All right, again, this is not on a unit circle, so maybe we can use a triangle where cosine is the adjacent over the hypotenuse. So the adjacent is 2, hypotenuse is 3. Use your Pythagorean theorem to get the opposite side. So our opposite side is the square root of 5. Now this could be a positive or a negative, but our inverse cosine is always in quadrants 1 or 2. The y there, the vertical, is always positive, so we'll have a positive square root of 5. So now, that's the inside, so now what is sine of that? Sine is the opposite over the hypotenuse. The opposite is the square root of 5, and the hypotenuse is 3. So you evaluate the inner, and then evaluate the outer. Let's make it more interesting and make it x. Well, our tangent is, since it's just x, it's not the unit circle, but tangent is the opposite over the adjacent. So if we have a triangle, the opposite would be x and the adjacent would be 1. We could use the Pythagorean theorem to find the hypotenuse. So x squared plus 1 squared equals my hypotenuse squared. So the hypotenuse would be the square root of x squared plus 1. Secant of that angle now, so we did the inside, now we're doing the outside. Secant is the hypotenuse over the adjacent. So the hypotenuse is square root of x squared plus 1, and the adjacent is 1. Should probably write just the square root of x squared plus 1.